This is Pre-Calculus Section 4 Point Notes, Part 2. Sorry, I guess I didn't quite get to finish this example in the last video. So we plotted our points here for our new graph by just shifting our points up 3. So that one is represented by the purple graph on my screen. And of course my asymptote there is highlighted in green, and that asymptote is still at x equals 0. The domain of my graph is where it lives along the x-axis, and my entire graph is on the right side of that asymptote. So my domain is x is greater than 0. In interval notation, that would be 0 to infinity. My range is where my graph lives along the y-axis. The arrows go down and go up both directions. This graph lives everywhere up and down. So my range is y equals all reals, or in interval notation, negative infinity to positive infinity. And so I have a little note here regarding our asymptote. Vertical shifts do not change the domain or the vertical asymptote of log functions. What does change these things is horizontal shifts, h values. Okay, and we will get to that in our next example. So now we're going to graph y equals log base 2 again of x plus 2. So now our parent here, I'm going to go back to red. Our parent graph is just up to the x. So this plus 2 that we see right here, this is an h value. Remember, it's opposite of what you see. So since we see x plus 2, that means that h is negative 2. So that's going to be a shift 2 to the left. Okay. So once again, remember, if you want to make a table, that's fine, but then you need to graph your parent function and just change it to exponent form. So if we were going to do that, we would graph the equation 2 to the y equals x, and we would plug in y values, which is the same thing that we did before. Okay, so I'm going to go ahead and I'm going to sketch the points for that parent graph. They are at 1/4 negative 2, 1/2 negative 1, 1, 0, 2, 1, and if we had it on here, it would be 4, 2. So there's the points for my parent function. So now if I'm shifting everything 2 points to the left, that is going to be my final graph. So if I just move everything over 2 points to the left, that is what my final graph is going to look like. So you can see that my asymptote is moved. My asymptote is now the vertical line at x equals negative 2 right there. That's because I had that horizontal shift 2 to the left. So my asymptote is at x equals negative 2. My domain has changed as well. When my asymptote moves, then my domain changes. So now my domain now is x values greater than negative 2, or in interval notation, from negative 2 to infinity. My range, however, does not change. Always all reals for logarithmic functions. And in interval notation, negative infinity to positive infinity. So I just have this note down here at the bottom of the page, and I talked about this as we graphed. You can graph a logarithmic function with an XY table if you don't remember what the parent looks like, but if you choose that method, it's much easier to first rewrite the log equation as an exponential equation, and then choose your y values in your table, plug those in to get your x values. That is the easiest way to do it. Whenever we talk about logs, we always have to talk about what type of base we are dealing with. All the graphs that we've made in this section of notes have been log base 2 graphs, but log base 2 isn't the only kind of base. You can have any base. The common log is called the common log because it's the most frequently used log. These logs have a base of 10, and there's a special notation for log base 10. If you are talking about a log with a log base of 10, then you just write log x, okay? So note, you do not write the base. If it is 10. Okay, now that's only true for log base 10 because it's the most commonly used log, so we just drop the base and we just write log x. But everybody knows that if you see the word log and you don't see a base, that is a base of 10. That your calculator will calculate a base of 10. The other log that your calculator will do is a natural logarithm. These have a base of e. And the notation for our natural logs, there's also a special notation. You won't ever see it written like that, as log base e of x. Instead, you will see it written as lnx. So that's the ln button on your calculator. And then we have some properties of natural logarithms. Okay, ln of 1 is equal to 0, and that's because anything to the 0 power is 1, right? So if the base is e to the 0 is 1, and then natural log of e equals 1 because e to the first power has to equal e. So for our last examples today, we're just going to practice using the LOG and the LN buttons on the calculator. Sorry about that. So grab your calculator and we're just going to type these in. Example number 1, log 42.5, you should get 1 point, oh boy, struggling here. You should get 1.6284. In example number 2, natural log 7, so you hit ln 7. Get in the habit of closing the parenthesis because with a natural log it always pops up that parenthesis for you. Get in the habit of closing it just in case you have other things after the parenthesis. You want your calculator to calculate correctly per the order of operations. This one should give you 1.9459. And then the last one, log of 132, this should be 2.1206. And again, if you have any questions about using your calculator to do either log base 10 or log base E, please come and see me so we can get those figured out.